Alrighty. So you guys, this is concentrations and dilution lecture video 6. And I know I'm skipping around, but this is basically how I introduce these last couple of topics over these chapters 11 through 13. But the next problems that I want us to look at is going to be found on page 535, and these are practice problems C. All right, and I'm going to start with number 1. And so number 1 states, prepare 1 liter of Lysol 3% from a stock solution of Lysol 10%. So in detail, right here, before we get to the question, I want you guys to know or identify some information. First things first is that the 3% and the 10% are considered concentrations. And in detail, these concentrations are expressed as percentages. That's first things first. I want you guys to keep that in mind. All right. Now, whenever you hear or whenever you read a problem and it says prepare, all right, this means whenever you see that term prepare, this means that this is the prescription or the desired medication. So, when you're looking at this problem, all right, and you're identifying some information, I always tell you to ask yourself question number 1. What type of problem is it? Well, it's a dilution problem because there are two concentrations which are expressed as percentages. Question number 2. Question number 2, or step number 2. Identify the components. So C1, which is your stock concentration, which is always your highest, is going to be 10%. Your Q1, which is the stock quantity, well, in this case, you don't know what it is. It's X. All right. My C2 is my desire. Whatever you're preparing is your desired concentration and your desired quantity. So my C2, which is your concentration number 2, is 3%. It's always going to be C2 is always going to be lower than C1. All right. And Q2 is your desired quantity, and whatever it is that you're preparing is your desired quantity. It says to prepare 1 liter. Well, it has to be in milliliters, so it's 1,000 milliliters. All right. So that's question number 2 is, can you identify the components of your dilution problem? All right. And we've done that. Or I've done that for you. So now that you have this information, your question number 1, or A, 1A, says how many milliliters of stock solution are necessary to prepare are necessary for this preparation? Well, in order to solve that, you're going to have to use that formula. In order to solve A, you're going to have to use that formula where you do C1 times Q1 equals C2 times Q2. We know that our C1 is 10, Q1 is X, C2 is 3, Q2 is 1,000. All right, that's 10X equals 3,000. You're going to divide 10 on both sides, and X equals 300 milliliters. You're going to need 300 milliliters of the 10% in order to prepare 1,000 milliliters to equal to a 3%. All right. Well, that makes sense. What I want you guys to keep in mind that your C1 is always going to be your highest concentration. Your C2 is your desired concentration. It's always going to be lower than C1. Your Q2, which is your desired quantity, is always going to be higher than Q2. And Q1 is your stock quantity. It's always going to be lower than your Q2. All right? You need to keep that in mind when you're identifying your components. Your C1, which is your stock concentration, is always going to be higher than your C2. Your C2, which is your desired concentration, is always going to be lower than your C1. That makes sense because the definition of a dilution, is that you are to dilute a stock medication and lower its strength. All right. Let me go ahead and change this really quickly. This Q2 should be higher than Q1. I want to make sure that I reiterate that. All right. All right. So let me just rephrase what it is that I'm saying. When you're identifying your components, all right, keep in mind that your C1, which is your stock concentration, your C1 will always be higher than your C2. This will always be higher than your C2. All right. Your C2, which is your desired concentration, will always be lower than your C1. Okay. Your Q1, which is your stock quantity, meaning how much of that stock medication do you need in order to make this new concentration. All right. It is always going to be lower than your Q2. And remember, your Q2 has both the desired quantity and it has the components or the quantity from your desired medication or your base and your concentration. So your Q2 is always going to be higher than your Q1. All right. Remember that your Q2 is always going to be higher than your Q1 because the components that make up your Q2 is the stock medication and whatever base you're using to dilute the stock medication, whether it's water or normal saline. All right. You add the two together, you're going to get a higher number. I want us to go ahead and let's go ahead and look at B. All right. Same problem, number 1, but we're looking at 1B. The question is, how many milliliters of solvent are necessary for this preparation? How many milliliters of solvent are necessary for this preparation? So basically what they're asking is how much, they're asking how much of the final preparation, which consists of your stock and your base, how much of it is base? That's basically what it's asking. It says how much of the final preparation, which consists of your stock and your base, how much of it is base? That's what solvent is. Solvent is just asking you, you know, what was added to the stock medication. Your solvent could be, it could be water. It could be normal saline. It could be normal saline for injection. All right. It could be distilled water. All right. It could be either of those. But when it's asking you how much solvent was necessary to use, they're asking you how much base was necessary to use. In order to solve that, you need to remember this formula. Q2 minus Q1 equals the solvent. So basically, you're going to take your desired quantity. So from the problem, you know your desired quantity, what you prepared was what you prepared. All right, so you guys know that what you prepared is 1,000 milliliters. So you're going to take 1,000 milliliters, which is your Q2, and subtract it from your Q1, which you guys have determined was 300 milliliters. All right. You subtract the two, and that means that 700 milliliters of the preparation is of solvent. What that solvent is in detail, we don't know because it doesn't tell us. It doesn't tell us if it's water or normal saline or sterile water for injection. It doesn't tell us what the solvent is in detail, but you can determine how much of this medication has solvent in it. All right. So I'm going to stop here and we are going to pick back up with another problem.